monsoon onset, and I will also be discussing where does 2022 stand in terms of bogus monsoon onsets. So let's start the discussion. This is just to give an idea of onset criteria as defined by IMD, and on the right, I plotted the plot. I plotted OLA mean for June from May last week to June first week, like centered on June 1st, so that since June 1st is the onset, climatological onset date, I plotted the mean OLA and 850 HPA level winds here. So let's first discuss the onset criteria as IMD want it to be. So there should be after 10th May. This is very important. So first, they will be looking at the rainfall criteria or whatever the criteria we are discussing here only after 10th May. So after 10th May, there are 14 stations in Kerala, all the way from South Kerala to North Kerala, if I am right, and even Mangalore and Karnataka. So if all these stations report 2.5 mm or more rainfall for 2 consecutive days, then the onset will be declared on the second day, provided the following criteria below satisfied. One is the wind field. The first criteria is depth of the westerly should be maintained up to 600 HPA level over box from 10 north, from equator to 10 north and 55 to 80 east, and zonal wind speed over the box 5 to 10 north and 70 to 80 east should be of order 15 to 20 knots. That is at 925 HPA. And then outgoing lower radiation should be below 200 watt per meter square in the box confined within 5 to 10 north and 70 to 75 east. Here, I don't know if it is visible, but I plotted the box corresponding to the second criteria, which is 5 to 10 north and 70 to 80 east. As you see, the OLA pattern, or just notice the OLA pattern as well. We'll be coming back to this later. So here in this discussion, I would start looking at the criteria, or I will be starting by discussing the paper called Dynamics of Double Monsoon by Fletcher. It was published somewhere around in 2001 in Journal of Climate, and I use this paper for kind of reference because the criteria they use here for double monsoon onsets are much easier to understand, so that everyone can easily understand. There are many other papers that could published after this, but this paper could be easily understood by the studies. So moving ahead, so in this paper they describe 1995 as the most beautiful year of double onset or bogus onset. And I would start here with we will start here with looking at the OLA pattern. This is the Homola plot, and you see MJO signature of MJO starting the pulse of MJO that started in the Western Equatorial Indian Ocean close to 1st May, and it propagated all the way to the West Pacific. So this is where events started unfolding during '95, and what this MJO event did was it produced, according to Wikipedia, it says there are 2 deep depressions in close succession, but I feel that it is a single system that made initial landfall over Kadalur in Tamil Nadu on between May 5th and 7th, and then it re-strengthened and hit Andhra Pradesh near Tuni, between May 8th and May 10th. But as we go further, the signature of this deep depression remains till, if I am correct, 16th May. The signature can be seen all the way till 14 to 16 May, somewhere around that point. But the thing is this, so the first thing that happened was an MJO pulse got initiated in the Western Equatorial Indian Ocean, and it generated a cyclonic circulation which strengthened into a deep depression status according to IMD criteria. And then the depression persisted in the Bay of Bengal all the way till between here it says 8 to 10, but you will see later that the signal exists all the way up to 16. So that's what it is. That's how it started in '95, and then these are the weekly average plots from May 3rd to 30th May. And again, these plots are 850 HPA wind levels and OLA. And you could see that between 3rd and 5th May, there is a lot of convection happening in the Bay of Bengal, and there is a lot of convection in the Southern Indian Ocean as well, because whenever MJO pulse comes here, it generates basically 2 vortices. I will show it. I will show a nice plot or nice OLA plot of convection for 2022 case, but you have twin vortices even in this case is what the paper argues. And then you see between 10th and 16th March, you can see the circulation over between North Coast Lake and South Coast Odisha. and you could see the westerlies build up here itself, but you could clearly see that the westerlies are touching Kerala in between 10 and 16 March or 16 May. But these are not close to what we say. These are not close to climatology anyway. You don't see much rains in Kerala. The Ola is not as high as it is in the climatology report. So I don't know, but they still call it bogus onset. But when you come to 17 to 23 May, everything changes. Like you don't see any strong westerlies here. And over India, it's all OLR is about 260, so there is not much rainfall happening over the Indian subcontinent. And by between 24th and 30th May, yeah, you could clearly the westerlies are almost absent. Yeah, there is no signature of westerlies, and you could also see that initially when the system had set up, it draws the cross current. But this cross equatorial current also kind of gets weakened by 24 to 30th May in 1995. So this is how the events progressed. They call it beautiful onset, but I don't see any pattern of onset during 90. That's what it is. So let's go ahead. So what the criteria they use for multiple onset is they used surface kinetic energy, vertical wind shear, which is a vertical wind shear of horizontal wind, which I suppose is zonal wind according to them, and vertical shear of meridional wind. So what they did was they averaged all these variables in the box between 5 and 20 north and 40 and 110 east. So from this figure, you could clearly see that this plotted between May and September timeline. And there is a sharp increase in kinetic energy over the box just before the cyclone sets in, and it peaks along with the cyclone. The kinetic energy peaks along with the cyclone, and it is kind of followed by a sharp decline in kinetic energy just after the cyclone. And June, yeah, I have to mention that in 1995, the official onset date was June 9th, according to IMD. And it's again in the June first week or somewhere around that, you will see that there is an increase in kinetic energy. And then after that, there are drops in kinetic energy and increase in kinetic energy, but they are all associated with the active and wake spells, I would say. And the same pattern can be seen here in the vertical zonal wind shear. So you could see a sharp increase in zonal wind shear. Probably this is because of cyclone-induced convection over the Indian subcontinent, and then there is again sharp decline in the vertical wind shear, zonal wind shear, and followed by again sharp increase, and then the wind shear continues to be above some threshold, say about 20 meter per second once the monsoons set in. The same is the case with meridional wind shear, and meridional wind shear also kind of shows a peak that corresponds to the cyclone, and then there is sharp decline, and then yeah, once the monsoon set in, the variation is not much. So one thing that clearly sets apart if something is a bogus onset or not is the sharp increase and then sharp decline in the parameters shown here, like kinetic energy, zonal wind shear, and the meridional wind shear. So please keep this in mind. We will come back to it when we discuss about 2022. And this is the evolution of zonal wind shear, same as the plots I had shown earlier between 3rd May and 30th May, weekly plot. And you would see between 3rd and 10th May, the zonal wind shear is, yeah, you could see zonal wind shear is positive only up to some part of Indian subcontinent, southern Indian peninsula, I would say. But with the development of cyclone, the zonal wind shear kind of increased. And from 17 to 24th, you would again see the trend of decreasing zonal wind shear. The zonal wind shear, I would say, is highest if you consider the box which we had discussed earlier. It would be highest between 10th and 16th May. That is when the cyclone or deep depression is active in the Bay of Bengal. And this is the onset climatology. Sorry for this. I mean, it's not clearly visible with the winds, but onset looks like this. For the onset climatology, this is also centered at June 1st. And the onset climatology looks somewhat like this. You have a strong positive wind shear or whole southern peninsula, and yeah, positive wind shear up to almost 20 degrees north. That's what. Just keep this in mind. This is what onset climatology looks like. But yeah, here it looks somewhat closer to the onset climatology between 10 and 16, but there is a sharp decline in the zonal wind shear. So I don't know, the structure doesn't look like onset to me, but since this paper calls it as a beautiful onset, let's assume for a moment that it's a bogus onset or beautiful bogus onset or whatever it is, and move ahead. So now we'll come to 2022 now. What is the similarity of 2022 with 1990 is this timelines. In 2022 also MJO pulse started in the Western Equatorial Indian Ocean at the same time almost. And by 8th May, we could see strong vortices generating, one in the North Bay of Bengal and one in the North Indian Ocean and one in the Southern Indian Ocean. And this developed led into a severe cyclonic storm named Asani, and then it caused Andhra Pradesh close to Machilipatnam. This is a picture from May 10th, and I was there in this thunderstorm. Actually, I was traveling home to intercept the cyclone just for the purpose of intercepting the cyclone, and I was here. And one thing I would say is, if you look at this convection, which is not so clear here, but the cyclone center is somewhere here. It is to the north. It is to the northeast of me, and maximum of the convection or the rainfall is kind of confined to southwest territory of the cyclone. And I went all the way up to Rajahmundry, which is in the northeast, and as per my experience, there is not much rainfall there. I expected there would be much more rainfall there, but this structure kind of looks similar to monsoon depression more than a cyclonic structure, is what I would say. And yeah, that's what it is. So that is the similarity. The similarity is that both the years started with MJO pulse, and both the years started with a cyclonic circulation, and which eventually here strengthened into a severe cyclonic storm. And let's look at the evolution of the winds in the case of 2022. Yeah, it's all clear. You could see a MJO signal here with two vortices on both sides of the equator, and Eastern Equatorial Indian Ocean. It is getting a lot of rainfall, and then between 10th and 16th May, you could see this is where the cyclone made landfall. You could see a cyclonic circulation, but most of the rainfall is confined to the southwest of the cyclone, just like a monsoon. How you expect a monsoon depression to act or behave. And between 17th and 23rd May, you still have strong convection across southwest India and Arabian Sea, along with there is strong convection going on in the Bay of Bengal. And you have strong westerlies at 850 HP level. And westerlies here continue, I guess, all the way from here. Even between 24th and 30th May, there is still signature of westerly. It is missing India. The strong westerlies are missing India. They're going little south, but the signature is still there. So I feel this is, if it is to be called bogus, this comes much nearer to bogus than the 95. But let's see if it is the case. And this is the shear evolution, and you could see, yeah, shear kind of is developing till 15 north between 3rd and 9th May. Between 10 and 16, you see most of the India has positive value. Yeah, shear I calculated as a difference between zonal wind at 850 HP level and 200 HP level. So it will be positive if it is if 850 HP level, then if it is easterly, if the shear is easterly, it will be positive. So, and you see between 17th and 23rd May also, you have a strong signature of shear over the Indian subcontinent. And even between 24th and 30th May, you see strong signature over the Indian subcontinent. And if you ask me, this looks much closer to the onset climatology. Between 17th and 23rd May 2022, it looks much closer to the onset climatology. And shear, as you're seeing here, it is not decreasing after the cyclone has passed. Actually, it still maintains its intensity after the cyclone has passed. So what I did was I also plotted the kinetic energy for 2022 case. I downloaded the data from NCPD analysis system, but unfortunately, data is only available until 31st May. So I can only show between before 31st May. So I plotted it from April 28th to May 30th, and you could see this peak here corresponds to Asani cyclone, and that peak is also present in zonal wind shear. Meridional wind shear, I don't see. Yeah, there is a peak, but it is not very substantial. Yeah, one thing common is there is a peak corresponding to the Asani cyclone, on cyclone in the Bay of Bengal, and then kinetic energy. You can note that this decrease is not as far as it was in the case of 95 degrees. And then something happened, and again the kinetic energy rises up. And if you look at here, this rise starts post May 20th, and the same is the case with the zonal shear. So zonal shear, there is a dip in the zonal shear, and then again the zonal shear kind of it increases monotonously till May 30th, and then there is a slight dip. That's what it is. So it doesn't look anywhere close to what is shown in Floto et al. Paper, and I don't know. So I won't if the papers doesn't show the decrease in kinetic energy and other parameters and then sharp increase before original onset. I would consider this as an onset only because after the cyclone I had left us, something caused the kinetic energy to increase rapidly, and we don't know what that is. So if that paper is to be believed, I would consider this is not a bogus answer. I should consider this as an indication of early onset of monsoon in 2022. So that's what it is. There is a quick recovery in kinetic energy and zonal wind shear, and the forcing for second peak is not the cyclone. That is key. Unlike 1995.
I mean, can we really then call it monsoon onset and then there was a long delay?
Yeah, that's what I am thinking. I mean, it's not that clear. We need more data because the data is not available after 31st May. I can't do much. June data will be available only from NCP after June ends. So we need to look at it. It needs some data to end this.
So on May 20th, all the criteria were met for onset.
Yeah, except probably 600 winds depth. Yeah, that was not met because I'll tell you the reason in a while.
So I said that based on Bangalore experience, we had almost 2 weeks in May, like after 10.
Yeah.
Almost July.
Yeah.
So anybody who doesn't look at all this would have thought it is monsoon.
Yeah.
Right?
Actually, May 17th is a day when Bangalore had a lot of rainfall. Some areas the rainfall was as high as 150 mm, if I remember.
Exactly, overall cloud in the air and
Yeah.
winds.
Yeah. Can I move ahead? So, what is the possible reason? I kind of attribute it to a tropospheric vortex. If you look at the 600 HPA wind level, it is all around between 16 and 20th May, and see, it looks like very close to climatological Ola when monsoon's onset happened over Kerala. And when you look at the 600 HPA level, you see that there is a mid tropospheric cyclone, which Pradeep knows it much better than me, which we have seen in Pradeep's Kollaikem. This shows the signature of highest vorticity in the mid troposphere between 600 and 500 HPA level, if I remember it correctly. And that if you look at onset climatology of 600 level winds, yeah, you won't find the mid tropospheric vortex, but this mid-tropospheric vortex, I guess, is the thing that prevented that westerly wind depth to 600 HPA level, because this is sitting right on Kerala, and it is when you look at the areas to the west of cyclone, they have easterly winds. They should have easterly winds because of the cyclone. It induces the velocity in such a way. So I guess that this mid-tropospheric cyclone is one thing that prevented the 600 HPA level winds to be not as strong as the climatology, or the westerlies are not till the depth of 600 HPA level. Except for that, I guess every other criteria satisfies for declaring monsoon onset between 16 and 22nd May, so 16 and 20th May. 2022, and then I talked to Pradeep. Actually, he told that this mid-tropospheric vortex kind of is like it was induced. It could be induced by Asani, but without stabilized shear establishment, this kind of moving down of vortex is not possible. He says that this Asani remnant could have merged with the mid-tropospheric cyclone, which formed. So I don't know. We don't exactly know. We need more data to analyze it. But except for 600 HPA depth criteria, all the criteria were satisfied on between 16 and 20th May, and between 16 and even Ola criteria was satisfied. Ola, I guess the mean of Ola on those 4 days is close to 150 watt per meter square over the area which IMD suggests. So except for that, the conclusion is the mid-tropospheric cyclone caused extensive rainfall over southwest India, Kerala and adjoining Karnataka. Just reminding you rainfall on Bangalore May 17th in Bangalore, which I told earlier. So my take is that either we should have declared monsoon onset between 16 and 20th May, or we should have waited till June 10th. This is because actually the first picture in my presentation shows I was in Chikmagalur on 28th May, just a day before IMD kind of declared onset, and I could see strong convection building to the east of West Ghats and not to the west of West Ghats. And it's not what you see when you are in a strong piece of monsoon. And IMD declared monsoon onset on 29th, and it extended limit all the way to Kerala. all the way to Kannur. I would not have worried if it is only the onset close to Thiruvananthapuram, but limits extended all the way to Kannur. And yeah, that's what it is. So the summary is monsoon onset-like condition persisted after cyclone Asani, but unlike previous bogus or double monsoon onsets, westerlies did not vanish and they persisted for a long time after cyclone dissipated. The shear as well established is well established in 2022, and the cyclone structure resembled monsoon depression structure. The rainfall structure of the cyclone resembled like a monsoon depression structure, and an NPC formed over Kerala after cyclone dissipated and helped in dumping large rainfall over southwest India after the cyclone. All the criteria were IMD declared for onset got satisfied between 60 and 20, except that 600 SPA criteria. And I told that 600 SPA criteria is not satisfied because of NTC sitting over Kerala. And so the question is now, can we consider 2022 as a bogus onset? Like, should we consider this as a bogus onset or should we consider the relay onset?
We don't. But you know why I did not declare onset at that period? All the IMD satisfied, they were declared in time. Yeah. You have not done that. Yeah. Without asking, is there any reason?
Yeah, the 600 SPA criteria.
Okay.
That was not satisfied, but I would say that if on a certain year, we know about monsoon onset vortex as well. If on a certain year it happens that monsoon onset vortex just sits on Kerala like it's at this year, will they declare the onset or will they delay it?
But I think the wind after 6 days is a very good idea because for you to have monsoon trend, you need sufficient westerlies, bringing moisture into India. Yeah. So that I think is the most important criteria. Cyclone will not allow that to happen. Other two can happen due to any other synoptic event. But the westerlies being there up to 6, I think is a very important criteria.
And one thing is, if you assume that this vortex is not of Kerala and it is somewhere over here, it would enhance the westerlies at 600. It's just the position of the vortex. You assume that the vortex is somewhere here.
Yeah, but what is the average region? Look at what it walks into the average.
Yeah. Westerly at 600 SP level. Huh? You are talking about 600 SP level or?
Yeah.
600 SP level average is westerly, but it's not as.
No, but what is the left draw with the average?
Yeah, this is not this box. This is the last box.
Yeah, that's the whole point. Their experience must be great for. They have looked at it for 100 years.
Yeah.
So, although they didn't have much data before 70s, but their experience shows that unless there is enough westerly strength up to that, it is a bogus one.
But the thing is, if you argue like this, May 29th, you don't have criteria satisfied. The whole criteria is
then I would argue this year even 29th is wrong. That's my view.
The thing is, either this should be the most beautiful bogus onset year, or we should declare the onset year itself. That's what I say.
Okay.
I mean, this will defeat 1995 as a most beautiful bogus onset year if it is a bogus onset year. Yes. Because when you look at all the criteria, they are all satisfied, and even the patterns look very, very close to climatological patterns. Shear is very well established. So I guess either they have to declare this is bogus onset or declare here onset. And there is a large break as well. After 25th, I think there is not much rainfall over Indian subcontinent, and only now it is picking up after June 7th or something. Yeah. Now let's discuss monsoon 2022 so far. I had presented here the plot of June rainfall, and you see that for the first 15 days didn't go well. There is a deficit on every day. I mean, every day the mean the rainfall is lower than the mean, and then last 7 or 8 days it picked up a lot, and we now are at -2%, which is unbelievable because we all thought that.
Today it is good.
Yeah, by today it will be zero.
105.8 and 106.
Yeah.
So it's almost same.
Yeah, it is almost same. Yeah, which we never thought of. We thought it would be a deficit month. And when you look at the rainfall pattern, you see a lot of rainfall over our regions. Yeah. Bangalore, Rayalaseema, even Chennai got some very good rains. And there is a patch of lower rainfall west of Telangana, and this patch of rainfall, higher rainfall.
Northeast is very.
Yeah, northeast is very high. We have seen the floods happening in the northeast, and I have seen somewhere in Twitter that Masinram and Cherrapunji it was raining like crazy. Like one day it rained like 100 centimeters a day. Yeah. So northeast you have a lot of rains, and let's see how it is going to be. So this is the picture taken from Windy. And I don't know if you would satisfy the criteria of low pressure, but there is a circulation at least at 850 HP level that is forming. This is on 24th. This is focused for 24th. That is forming. That is going to form. And when you look at 600 HP level, there is one more circulation which looks like in a mid-tropospheric cyclone or circulation. And we know that when these two co-occur, they dump a lot of rainfall over central India. And we have to wait and see. My guess is, yeah, you'll be having a lot of rainfall for next 7 days over central India, and that would end as over like it would end as an excess. Like June will be excess by 5 to 10% is my wild guess. Yeah, this is the rain accumulation from ICMWF. Is also taken from India, and you see that there's a lot of rainfall. The patch of red which we had seen earlier now is covered with a lot of rainfall. So I guess that red patch would also kind of convert at least to normal is what I'm expecting. And this is the forecast for next 4 weeks. Unfortunately, I couldn't get it from IMD, so I have to take NCP CFS. You see the same pattern. The next week there is going to be a lot of rainfall. Yeah, this is the same region which we have seen earlier, which has really low rainfall, and that is going to continue. But South India, it's not a good news for South India. South India is kind of entering kind of break phase, I would say. And the third week and fourth week, I mean, I wouldn't consider them, but as shown here, yeah, even in the third week there is a positive rainfall anomaly sitting over central India, and even it persists in the fourth week, while South India still has to suffer. That's what it is.
So nice movement.
Yeah, actually, next 2 weeks forecast shows it much better. Like this anomaly here kind of moves to the north. Yeah, that's it. Great. Thank you. Yeah.
Can you show the location of the cyclone in 1995 season? I could not get it from the weather.
Okay. 1994, there is no clear cut indication, because here when you look at Wikipedia, they say that it made 2 landfalls, one in Tamil Nadu and one in AP. But when you look at the plot, you see the circulation is over here, North Andhra and South Odisha. That's what when you average it between 10 and 16. That's what it is.
And the break corresponds to, okay, so just after this week.
Yeah, just after this week there is nothing.
Oh, that's what the break.
Yeah, that's what the decline in all the parameters.
Yeah, more fundamentally, monsoons rains are this I always think.
If you go by IMD's idea, you have to include wind.
No, wind is certainly,
Yeah.
but you can have winds, but below threshold rainfall.
Yeah.
Do you call it as a monsoon? This is, for example, classic example this year in May. Almost all of India has had a conclusion. There were westerly winds all over India, right? But obviously the rain was probably confined to the southern.
Yeah.
So it's kind of a little bit confusing. Maybe there is one reason could be there is no sharp, spatial landscape here. For example, what I was, whether is it really good to define even when you say start of monsoon, you are really talking about an abrupt thing, right? You are not talking about a gradual thing. Does it really exist? Right?
Yeah. So one is remember papers published from FSU, remember on onset.
Yeah.
Based on cumulative.
Yeah.
That seems like a better way.
Yeah.
Remember you had a seminar here by what's the name, professor's name? I forget. Yeah. So
I missed that.
So they took from January they took cumulative rain, and then it was smooth. That looks nice, but it is not useful for real time because you don't have all the data. It is more looking at the past. So that looks very elegant. So each station they do, not average over any region. Every station they different answer for a very nice criteria. Right? You remember that?
Yeah. But even kinetic energy kind of works good. Like there will be sharp abrupt increase in kinetic energy. Rajat knows.
Yeah, but even cyclone will increase kinetic energy.
Yeah.
So how do you differentiate cyclone between just over the monsoon and monsoon?
Yeah.
Okay.
But I have a question for you. In 2022 case, yeah, the depth of westerlies is not up to 600 HP.
Yeah.
But for me, just after the cyclone left off and when the vortex, middle tropospheric vortex also disappeared, for me, there are still westerlies, but I guess they are missing India. It looks like a break phase of monsoon only when you go here. Like,
Yeah.
it looks like this looks like an active phase,
Yeah.
except the wind depth westerlies are not there. But this for me looks like a break phase of monsoon when you have winds coming down the Indian subcontinent. They're not touching the Indian subcontinent.
But actually, the main issue here is not answered over Kerala alone.
Yeah.
Before the advent of satellite, Kerala was the most important station for watching onset of monsoon, right? To me, now we should go away from that. We should look at the onset over central India, not Kerala. Kerala is fine, but Kerala doesn't define India. Okay? How people don't mind. Central India is the heart of India, okay? For example, right now, Northeast is always going opposite to India. So, for example, you may get normal rainfall for all India, but Central India may be below normal. So, the Central India is a key criteria. So, I think, I don't know why nobody has come with a proper criteria for onset. Aditya has done it. Aditya is not here now. Aditya has done it. He has defined onset over Central India by criteria. And one should check all going back as far as possible. To me, that is more relevant than onset over Kerala. Because you can have onset over Kerala, then there can be a long delay before IT season comes over Central India, right? So
this IT season now coming over Central India is not coming from south actually. It is forming over Indian subcontinent itself and kind of punching. But yeah, probably it's not a part of this discussion.
yeah, but eventually, although we all talk about IT is moving from south to north, in reality it's more complicated.
Yeah, it's complicated.
There's something happening east-west. But we are saying that we saw over an average of a few days, we saw the rainfall band is shifting from Kerala, not continuously, but step by step, and it reached already Mumbai now. And it's very well organized east-west.
Yeah,
that is the heart of monsoon, not your onset vortex or onset.
So, I think the criteria is India rainfall over a specific threshold, continuing for 3-4 days or something.
Yeah.
I mean, so basically those are all integrated measures.
Yeah.
They are better than these single point measurement like
But no, IMD is not single point. IMD uses rainfall over whole of Kerala.
Smaller region.
And a region, one large region. That they arrived at a lot of experience. So they choose the whole of Arabian Sea almost. From Kerala all the way across. They get the whole Somali Sea. They do that correct.
Still, I think it's a smaller domain compared to Indian, whole India.
See, there is a question of history here. Since Shear also was defined a long time back before satellite came, whatever IMD does now has to be consistent with that. That's always the problem. You cannot ignore the history. It's the history of everything, right? So you have to continue on that. That's why when someone is foreign author, they don't pay enough attention to Indian author. This is the common all over the page. So if the paper they talked about it, they consulted all the other Christian and IMD work, they would have done such a good job. But they don't ignore it. And depend only on OLR. OLR is fine because your satellite data are very high quality, but you have to look at wind and rainfall also. And so I think IMD has spent enough time on it, but they have to make sure that whatever they depend now is consistent with 1901 onwards. Otherwise, there are problems.
Yeah.
So that problem is there. Yeah, we may not try in academic settings, but for an organization, they have to make sure that whatever they do goes back directly to the past. So that problem is there. Because remember, before satellite came, Kerala was the only way to depend on onset. And we can go wrong. We can be local rainfall and it's not monsoon at all, right? Okay.
This is about you were talking about some the next forecast. There is some like somewhere near Bombay. I mean that I think maybe it's worth looking at. Every year you look at when Bombay gets.
Actually, Pradeep has done work on metro bus.
It's not a large scale feature. It's a very tiny feature. In the wind flow, you can see cyclonic. I can show you. If you look at the next 10-day forecast winds in IMD. Not this wind. Okay. Something else. It's a very small thing. I would rather call that as a mesoscale feature.
Okay, not this one.
Not this one. I think I can show you. It's the 10-day forecast from GFS, I think, whenever Bombay gets heavy rainfall, it's actually not a very big, broader cyclonic pattern. It's something associated, I mean, today it looks like more to do with the topography. You have a heavy westerly flow, and that's maybe one of the investigating that you're interested in. Actually, if I go and look at the small scale feature of that, small cyclonic, it looks to be more like an associated system.
Yeah, well, I can give an example. On 8 June, when this system didn't work, I gave my presentation. I showed that IMD had predicted 122 millimeter rainfall over Pune, 122. Now, there was no rain. Okay, but if you look carefully at all the rain gauges around Pune, then the place was down. Right? Just to east of Pune, about 40 kilometers. It rained heavily there, 50 kilometers, 60 millimeters. So that's the problem. There are lots of smaller scale systems in that area because of the Western Ghats.
I always wondered why Bombay gets so much rain. On the West Coast, if you look at it, Bombay is somehow.
No. See, you mean Bombay, along the West Coast, Bombay doesn't get the highest rain. There are lots of heavy rain, Ratnagiri and Karwar and Goa, all others they get much more rain. Bombay not the highest. No way. See, I can show you that next week, no problem at all. If you go along,
Maybe I can send that small feature.
Yeah, but on certain days you're right. On certain days, the famous 1,000 millimeter rainfall in Mumbai, 2005. That was totally because it's very small.
Yeah, but yes, it was embedded in a big process.
Yeah.
It's not a completely isolated system.
Yeah.
It was kind of.
It's embedded in a big system. But predicting that kind of resource is very tough. That is why. So what happened in Pune that day was that there was a rainfall, heavy rainfall right just to the east of Pune. I mean, you can't get it right within 50 kilometers. That's impossible. That's a huge, in spite of resolution now reduced is 12.5. Still, it's tough to get it spatially right. Okay, I'll add a few more things. They've done a good job. There are a few things more. Let's see. Where is that?
Yes, can I make a comment?
Sure.
Am I audible?
Yes.
Okay. See, I am very much confused because if you use words like onset and onset, historically, they have been defined a certain way. Now, the way onset is defined, and you showed the IIT criteria and so on, and you volumes written on it, and a major review paper by Joseph. See, onset means the beginning of the rainy season. So you have to ensure not only that there is onset occurring over Kerala or wherever, but the system sustains itself and actually run further and gives us rain. Okay, so all that has gone into the criteria they have done. What you have done is your onset over Bengal, not at all over Arab Sea. And what you call bogus onset is also not what is traditionally called bogus onset. I think, see, I'll tell you, over the Bay of Bengal, all there are severe cyclones in April and May. Okay, May 11th you got a cyclone this year, but I will show you many years which this nobody is at the onset because it is not the beginning of the rainy season. So I believe that when you use words like this, it is important to specify what you mean, and otherwise what happens, everybody gets confused. The traditional meaning and what you are trying to reduce. I identify bogus onset also. I'm sorry, I didn't see the paper you flashed very fast. What paper is that? Paper on which you said 95 is a very famous case of bogus. What was that paper?
No, 95 paper is flat out.
Flat out.
Okay. See, Jay, the problem is that there has been a lot of work on that and bogus onsets also. Okay. Now the way it has been defined in this talk is totally different. And this is why I find it difficult to understand why the same things are used. See, what you saw on 11th May was not created by any imagination. This is my claim, okay? What you got was a cyclone in the bay, and that happened often. So, in fact, I would like Dr. Aditya to respond.
Do you understand? Sorry, your voice is broken. I didn't follow all of it.
Huh? Hello?
Yeah, I think you can follow all your.
Pardon?
Hello, we can follow all your statements. You can
Yes.
send email and then.
You know that onset of monsoon is generally monsoon onset over Kerala. And why is that? Because that is where it generally begins. Okay. Very often along with that there's also rain over the bay and so on. But the critical thing is that it has to rain over Kerala, and then the same system or a system generated soon after that has to bring in the monsoon over India. Okay. Now, by these criteria, by this, it has been defined for hundreds of years. What Dr. Aditya mentioned on 11th May is not the onset. Okay. First and foremost, he defines even 95 onset as onset over Andhra. Now, this is a very peculiar definition, and while I have nothing against it, unless you link it with the traditional definition, it's not going to make sense. And particularly using words like bogus onset, which have definite connotations on which there is so much literature available. I do not believe that it's right to define your own systems and then use these words. So I'm sorry about this, but that's why I was very confused.
Okay, well, yeah, the word bogus is somewhat derogatory, I agree. Some implying that they didn't do a good job. That's true. Okay, let me say a few words. This opening slide is what I shown 7 years ago. This just to remind all you people that 170 years ago, when people thought seriously about forecasting because of trade. 170 years ago, only trade was ship. And ships were getting into deep trouble during bad weather. So the naval people in England suggested that you can collect some data around England and do it, but none of the politicians believed it. So you must remember that whenever somebody gives a new idea, one cannot throw it away. But today we can forecast it. Now this is the.
But you use the same terminology to mean something totally different. That is all I'm saying. You call it something else. You see, this is a cyclone on the bay, and there is umpteen cases of cyclone in May in the bay, none of which have been referred to as onset. Okay, this is my worry.
Yeah, I agree. For example, same problem with active and wake cycle. It was defined quite nicely by MD, but people today use all kinds of definition of their own and confuse the issue. Yeah, I agree.
Yeah, I have no problem in re-looking at the problem. And what people fail all the time is that often cannot anticipate the forecast, anticipate what will happen in next 2 weeks. And that's what happened this year. Even if you take it as onset in June, after that there is a big lull, hiatus. So it is difficult phenomena, but I don't think you should use the same word for a different phenomena. That's all. I'm going to paper. It's not. Anyway, I'll stop.
Okay. Yeah. So this is the state of the progress of the monsoon as shown by MD, and this is the snapshot about 1.5 hours back. What I find very impressive is the amount of this is showing any region with from Rapid ISRO's website, any region 5 millimeters per hour rainfall. Okay, that's almost 120 millimeters per day. You can see whole of this region. There are so many small scale systems giving you 100 millimeters per day. Okay, so it's an unbelievably active system. But I wanted to notice that there is a eastern oriented line of rainfall systems here. This is what I would define as an IT season. And this already has been shown, there's nothing new here. Okay. Then this is the up to today, I managed to get this. And up to today, the rainfall accumulated 105.8, now 106, this is zero departure. Okay. And you can see that South India has done well except Kerala. Kerala always has been below the last many years. And interestingly, Rajasthan and this one got some pre-monsoon showers there, and of course, Northeast is gaining almost twice normal. And the system is still not reached here, which will do so in the next few days. And this is the report using numbers, not today but yesterday. And the point I want to make here is that if you look at Central India, it's 33% below normal, but all India comes close to zero. So that's because Northeast is 43% above normal. These two are compensating. So as far as Central India is concerned, the monsoon really has not come to that region. And if you look at the forecast, I'm quite impressed. This was forecast on 8 June for the next 10 days. Okay? Although not matching exactly, look at the rate of increase of all India monsoon rainfall from 14th onwards, which I mentioned on 8 June. That's almost getting correct, and also a decline. So I believe this is quite impressive that almost 10 days that they are able to get the right trend, not the exact numbers, the trend. And this is the next 10 days. And again, it's getting the numbers are not quite right, but it's getting the decline that starts occurring. It'll take a little bit more and then pick up. That's the plan. Now, Aditya mentioned that he thinks June rainfall will be 500% above normal. My prediction is it will be normal or below normal. Okay. Because you add up today's 105 millimeters, okay, and you take the next 10 days, assume it's around average, okay, that will be 70. So it will be around 170, okay, around now. Maybe if you're lucky, you may add a few more. So it will be normal June. Now, this is a prediction made based on April condition, okay, by CFS. And now, I'm not sure what the all India average is. I'm going to the fact that it predicts this high northeast rainfall correctly. So this will not change in the next 15 days. This portion will continue to be high. This we have to see in the next few days. If the Aditya really stays there and rains a lot, this also will be right. So I'm surprised that April condition is getting the monthly mean June rainfall. Spatial pattern seems to be somewhat right. And this is the forecast on June 16 by GFS and ESWF for up to July 1st, end of this month. Okay, and I wanted to notice that these two are quite similar, except for this portion. So we have to see whether ECMWF claims that Punjab and Delhi will get more rain. Delhi has a lot of rain today. Whether that will have an effect on 15-day average. GFS is not showing that. GFS is showing pretty below normal rate for that. Okay.
What initially on 16th June?
Huh?
That was initially on 16th June is what it says.
Yeah.
No, today's 22nd probably. It could have changed.
Huh?
Today's 22nd. Right?
I know. But even then, it is a 2-week prediction for 16 June. Okay. You can look at it. They keep changing every day. I'm not picked up the date. Now, this is trying to see how good the forecast based on 9th June. This is 9th June forecast, spatial pattern. This is the observed. Okay. Now, I'm quite, one day difference is unfortunately, I'm quite impressed by the fact that, of course, they got this right. Weekly average rainfall correctly. It's not too bad. All the colors are different. If you look at active numbers, not too bad. And here also, this is 8.2, this is 10.6. So I would say numbers are very close to each other. So I think the weekly average forecast also is not bad. And if you look at why everything is active around 16 June is look at the upper level divergence of the velocity potential. That clearly shows that this is what was missing all these days. It was somewhere here, now it's come over India, and this is what is going to keep the monsoon very active for the next few days. And this is from Bentley's website showing how the 19th June, how this thing will keep shifting, but it continues to be around India up to 3rd July. So this shows why Indian monsoon rainfall will continue to be normal, above normal till about 1st of July. And there is only one bad news, that is the Nino 3.4. Now, till 9th May, it was hovering around -0.8. Okay, it looked like this will continue and La Nina will prevail till the end of September. But this is amazing. I can't believe it. Next week we'll see, because sometimes things oscillate there. So this has gone from -0.8 to -0.35 in a matter of 1 month. Okay, that's rather unusual. So we need to watch, because if you remember, I mentioned this. If the La Nina continues with that at September end, I'm 100% sure it will be above normal rainfall. That's just from climatology. There are about 13 years where this happened, but if it is neutral, situation changes substantially. So whether the Nino 3.1 will continue to be -0.5 and below, or it will go below 0.5 is very critical. And this is surprising news, but this could be only 1 week. One can't look at 1 week's data too seriously. The reason why is very interesting. This we discussed in 2015. Around the equator, there is a very interesting wave which travels, okay, which causes upwelling and downwelling along the equator. And wherever the upwelling, temperature is below normal, downwelling above normal, and that unfortunately causes fluctuation in always average over fairly large region, but these things do have a problem. But so we'll see next week. This may move a little bit this way, and Nino 3.4 may come down. So that's the point to remember, that this is caused by the artifact of this waves traveling along the equator. There are papers on it. If you want, you can look at it. Now, the IRI prediction for Nino 3.4 is very clear. Statistical model says -1. Okay. Dynamical models say -0.5. And the mean of those two is -0.75 up to November. So if this is correct, this year's monsoon will be normal, above normal, no question about that. So let us see how true it will be. Okay. And now we look at how the La Nina evolves. There's a well-known discharging model, and so there the Nino 3.4 anomaly is in the y-axis, and the volume of the hot water anomaly is in the x-axis. Okay. Now what's happening is, this is 2020 when it was a El Nino and it rapidly cooled to become a La Nina. The whole 21 it hovered around here, and 22 is right here. All mixed up. Okay. And May, June, September you're here. Now the point is that we have a large positive warm water volume. Okay. So there's a positive that will trigger the temperature rise, and it will cross 0. The only problem is we don't know when. Okay. Now, if you look at the paper that has been published, in that paper they say there is a lag between this one and this one of 6 months. Okay, it's a very interesting lag. Very rare to have such a large lag. So, if the warm water volume increased to +8 here, then 6 months later, there will be a rapid rise in temperature. So 6 months from May, we are well past September, so we are safe. Okay, so that is the thing you can look at. Now, I just want to show an interesting paper from, I think this is from NCR down here. They are looking at how good are they in forecasting rainfall 24, 48, and 70 over in Islam. Okay, and this is based on the concept of false alarm ratio. Now, this way it is done is, if the rainfall event is forecast to occur and it's also observed, it's X. If it forecast to occur and it doesn't occur, it is no, and it takes a ratio of no to yes plus no. Okay, essentially failures. Okay, the point about this thing is very interesting is that if you're talking about just beginning of rain, 1 millimeter per day, around 50% chance will be right. And as you go to high and high rainfall, at number 64, you are almost guaranteed to fail. Okay? This is what you must remember. Heavy rainfall forecast is very tough. So I think this is a nice curve, and so I think the point to be remembered is if you want to predict heavy rainfall, 72 hours in advance is no good, but 24 hours advance you are not bad. See how rapidly it rises. Of course, best based on 1 week and sample data, I think, 7th June for this year. But I would ask whether they're going to continue to show this result. But this is a very interesting way to understand why heavy rainfall events are very often missed, especially 3 days in advance, but not 24 hours. Okay, I'll stop here. Thank you. This is the MGO, how it's going. It's now right over our region actually. Okay, thank you. So next week it is Karnataka, right? Yeah. Anybody have a question you can ask?